we are going to be revising lesson 11.2. So we will be focusing on learning objective number 16, which is verify trigonometric identities by transforming each side of the equation into the same form. So in today's session, we will be solving exercises 19 to 32. As you can see, I will show you the questions. And we will also be looking at the answer key, and we will be using the method of transformation for verifying the identity. So as you see on the screen, there are some suggestions given to you for verifying trigonometric identities. I will highlight here. So first, either you can substitute one or more basic trigonometric identities. That is, you try to convert everything into sine and cos. Or you use the identities you studied in lesson 11.1, like quotient identity, reciprocal identity, Pythagorean identities, and so on. Also, you can factor or multiply. Sometimes you need to use algebra, like the difference of square identity, a plus b multiplied with a minus b. And then one good suggestion that I will give you, especially for the free response question, is that you solve the left-hand side and the right-hand side separately, and then show that both are equal. Okay, so just as an example, you see here, the left side is on the left of the equal to sign. So this is the left side. This is the right side. So you begin with any one side and try to show that both are coming out to be equal. For example, if I take the left side, then this is 1 to the power 4 minus tan to the power 4 theta. So definitely we can use 1 square whole square minus tan square theta whole square. So this is nothing but your a square minus b square identity, which I already wrote for you here. So this will be 1 minus tan square theta and 1 plus tan square theta. Again, we can use Pythagorean because 1 plus tan square is secant square. And we can also convert tan square into secant square using Pythagorean. So which Pythagorean identity I use? 1 plus tan square equal to secant square. So accordingly, here tan square comes out to be secant square theta minus 1. And then I put it in here, plug it in, solve, convert everything into secant square. And you must be wondering why we did that, because the right side only had secant. So that's why we convert, and then both are equal. So when you say left hand side and right hand side are equal, means hence verified. Okay, so this is how you solve the question. Now let's come to the questions which are there in your EOT exam coverage. So these are the following questions that we are going to solve today. So first we begin with example number 3. There are two questions here, 19 and 20. I will do one by one for you, and then towards the end of the session, we'll be looking at the answer key also. Okay, so both sides are given. This is the left side, LHS. This is the right side. Now, as you saw in the previous slide, there were some suggestions when you have to verify. So this will come for FRQ, means paper-based. Show all the steps, very, very important. And even if you're using any identity, like Pythagorean, like algebra, like reciprocal, quotient, anything, just clearly mention that identity. So let's start with left-hand side. Now I will convert secant and tan into sine and cos, because sine theta, cos theta are my basic identity. So for left side, I first use reciprocal. Why do I use reciprocal? Because I know secant is the reciprocal of cos. So 1 over cos. And definitely, if I look at the right side, everything is in sine and cos. So that means I'm in the right track. Okay, what about tan? I can apply quotient. Tan theta is sine theta divided by cos theta. So I do that. And now it's pretty easy to see that both the denominators are same. Here also cos theta, here also cos theta. So I can take cos theta common, and I'm left with 1 minus sine theta. Now, is this equal to your right side? Yes. So hence verified. Okay. Very easy question to begin with on verification of identity. So make sure you show both left and right side and show that both are equal, and therefore it is verified. Okay, let's try question 20 also. Now in question 20, the left side is more difficult. So we are going to try and solve the left side. Let's solve it. So here I can use quotient identity. Tan theta can be written as sine theta over cos theta. Sine theta and cos theta are already in that form. So I just plug in it in for um, tan theta. So what do I get? Let's see. So I get 1 plus sine theta over cos theta divided by sine theta plus cos theta. Now I want to make the denominators equal. I want to take the LCM. So how can I make this 1 equal to denominator cos theta? By multiplying with cos theta up and down. And why I do this? So that the denominators become equal. And now I can take cos theta common. So next step, common denominator cos theta. On the top, we have cos theta plus sine theta. So this is the new fraction. And also don't forget the denominator. Denominator is sine theta plus cos theta divided by 1. So I just copy the same. Now, how can we convert division to multiplication? Because we really want to simplify things, I can see here that this term and this term are coming common. So they're going to cancel in the next step. So in the next step, we can write cos theta plus sine theta over cos theta. I convert this division. There was division here to multiplication. So in that case, I take reciprocal of the bottom term. So it is 1 over sine theta plus cos theta. Now, I hope you can see the common term. So this and this will cancel and I'm left with 1 plus cos theta. And we all know the reciprocal of cos is secant theta. So is it equal to the right side? Very good. So we start from left side, we reach to the right side. If both are equal, we have verified the identity. So this is how we solve question 19 to 20. We will now proceed and solve question 21. So this is question 21 and 22, again from Learning Objective 16, FRQ, verifying trigonometric identities. So let's start with 21. Now this is the left side. This is the right side. So I need to decide from which side I start. So first, let me start from left side. Then I will also do the right side. And because they are not in the basic trigonometric ratio, we will try to convert everything into sine and cos. So how can I write secant as reciprocal? It is the reciprocal of cos. How can I write cosecant as reciprocal? It is the reciprocal of sine. Okay, so I have the simplification as 1 over cos theta multiplied by sine theta. Now I cannot simplify further because there is nothing else I can do here. So let me now take the right side. So in right side, it is tan theta plus cot theta. And we know tan theta, cot theta are reciprocals also. So let me use quotient. So tan theta is sine theta divided by cos theta. And cos theta, cot theta is cos theta over sine theta. Now I want to make denominators equal. So I will go ahead, proceed and take the LCM. So cos theta multiplied by sine theta. When denominators are different, the product is the LCM. Don't forget. So numerator become sine square theta plus cos square theta. Now this is Pythagorean. Sine square theta plus cos square theta is 1. So 1 over cos theta sine theta. Now, do you see something similar? Yes, the left-hand side and the right-hand side both have come out to be equal. So if both are equal, we have verified the identity. So this is how you will show all the steps when you solve the FRQ paper-based exam. And you show very clearly how you reached the correct answer. Okay, let's do 22. Now 22, if you see this side is very simple. The left-hand side, I cannot actually simplify anything here. So I will begin with the right-hand side because this requires some bit of simplification. So RHS, I will take 2 sine square theta minus 1. Now, can I replace 1 with something? Anything related to Pythagorean that involves sine and cos? Yes, you're right. We can put sine squared theta plus cos squared theta. So this is the Pythagorean identity. I replace 1 with that. Why do I do that? You will get to know when I go to the next step. So in the next step, I open the brackets because there is negative sign. The bracket term will change sign. So it will become 2 sine squared theta minus sine squared theta minus cos squared theta divided by sine theta minus cos theta. Okay, now let us combine the like terms. So 2 sine square theta and sine square theta will combine. This will give you sine square theta minus cos square theta over sine theta minus cos theta. Okay, now we are ready to apply some identity. So on the numerator, we can apply a square minus b square. So this becomes sine theta plus cos theta and sine theta minus cos theta. So can you guess in the next step what is going to cancel? Yes, you're right. The negative term sine theta minus cos theta cancels. So I hope now you can understand the reason why we put 1 as the algebraic identity sine square theta plus cos square theta. It was done so that we can simplify and finally reach to the correct answer. So this is nothing but my left hand side, which was sine theta plus cos theta. So therefore, I can easily say that both sides are equal and hence we have verified the trigonometric identity. Okay, so very, very important questions in today's revision we are discussing. And I will be recording the session so that all of you, those who are not here, can also see this. Okay, we'll proceed now to some more questions. So next coming up is question 23, 24. So let's solve this question together. Okay, so again, this is a question on trigonometric identities. It has two sides, so let us see which side we begin with. Usually we begin with the difficult side, so I will start with the right-hand side because here we can plug in secant theta and cosecant theta values. Okay, the left-hand side is already in sine and cos, so there is nothing much I can do about it. So let's begin with right side. So in right side, we have reciprocal identities because secant and cosecant are reciprocals. So in place of secant, I will put 1 over cos. And in place of cosecant, I will put 1 over sine theta. So let's plug it in here on the right side and let's see what it becomes. So 1 over cos theta multiplied with 1 over sine theta divided by 1 over cos theta multiplied with 1 over sine theta. So this is the first and the most easiest step where I just use reciprocal identity and try to simplify. So let's see what will happen in the next step. Can I say in the next step, the denominator will simplify to 1 plus cos theta and sine theta multiplied so that I could take LCM and then simplify. So in the next step, this division, I'm going to change to multiplication. Okay, so just see how I'm simplifying. Cos theta, sine theta, and I'm sure you are able to see that something is coming common in numerator and denominator, which will help us to simplify the question in the next step. Okay, so this division, this one, I'm changing to multiplication. So can I say reciprocal will happen? So the reciprocal of this term. We are taking. So 1 over this was there. So it will become cos theta multiplied by sine theta over 1. This is the reciprocal. So when you convert division to multiplication, remember reciprocal happens. Okay, now I will be using distributive. How I use cos theta sine theta. Just see this cos theta sine theta, I'm going to distribute to 2 and I'm going to distribute to this term. Now you must be wondering why I did not take LCM. The reason is because when we do distribution at this step, you will see that some terms will cancel and we will get a simplified form. So this is very, very important question, 23, 24. Please pay attention. So I multiply 2 with cos theta sine theta. This is my first term after distribution. And the second term after distribution, if you say numerator, denominator same, cos theta sine theta divided by cos theta sine theta, same term. So I will cancel it. I will go back. Yeah, so I will cancel it and this becomes 1. So what's your final thing? 1 plus 2 cos theta sine theta. But are we at this term yet? No, not yet. So one thing you can do is to open this term. Either you convert this to the left side or you use the left side and do the conversion. So I'm going to do that one. So I will now take your left hand side and open it. See, this is A plus B whole square. So algebra, A plus B whole square. A square plus 2AB plus B square. This will help me. So I will open it. So I get sine square theta plus 2 sine theta cos theta middle term and cos square theta. Now you are almost near to the answer because you know sine square theta plus cos square theta. Pythagorean will be how much? 1. Very good. So 1 plus 2 cos theta sine theta. Now compare. The left side came out to be this. The right side also came out to be this. So both are equal. And if both are equal, have we verified the identity? Yes. So left hand side equal to right hand side, hence verified. Very, very important. Okay, now let's try question 24. And towards the end of today's session, I will also be giving you the final answer key to match your answers. Okay, now in this one, if you see, both have sine and cos. So it's a little confusing, you know, which side we begin with. So it's okay, you can begin with any side. So I will choose right side. This is left side. This is right side. Any side is okay. And we will be using here the concept of rationalization to solve this question. Let's see what happens. So 1 plus sine theta over cos theta. This is what you have. Now I want to convert this to this. Oh, okay. And something similar. So what I will do, I will rationalize with the same term, different sign. So here sign is positive. So what will be the rationalizing term? Same term with negative sign. I hope you understand. So 1 plus sine theta, if we want to rationalize, we will multiply up and down both sides with 1 minus sine theta. Just change the sign. And the reason being why we are rationalizing, you must be thinking, is because we want something similar to the left hand side. So now a plus b, a minus b will be 1 minus sine square theta. The numerator simplifies and denominator multiplies. This one. Now we can very easily identify that this is nothing but Pythagorean. So 1 minus sine square is cos square theta. So your cos theta from the numerator and denominator will cancel. So 1 cos theta is gone. This cos theta with 1 cos theta. So 1 cos theta is still left in the numerator. So what you're left with? Cos theta over 1 minus sine theta. Now, is this right side? Sorry, is this left side? Check. We start with right side, this one, and we reach this side. So both have been proved to be equal, hence verified. Okay, so that completes question 23 and 24. And by now, I hope you have understood one important point, that there is no definite method to solve questions on lesson 11.2, verifying trigonometric identities. You have to apply your brain. You have to practice a lot so that you can reach to the correct step for each of the questions. Okay, so with that, we are ready to proceed to the next question. So 25, 26 coming up next. Let's solve 25. Now it's very easy to identify here. This is the left side. Here, this is the right side. Tell me which one is more tricky, which is more difficult. This one. So we will start from right side. We will try to simplify right side and bring it equal to the left side. Okay, so let me write it again. So this is cosecant. Huh? Now I want you to think what can be done. See, whenever you see a term like this, it doesn't matter it is a numerator or denominator, like cosecant theta plus 1 or cot theta minus 1. You know you have to do rationalization. So what is the opposite sign of cosecant theta plus 1? It is cosecant theta minus 1. So that is how I rationalize. And when you rationalize, you multiply the same term up and down so that the equation does not change. Okay, so now let's see what we get. So in the denominator, after rationalization, you will get cosecant square theta minus 1. And in the numerator, you have cot square theta cosecant theta minus 1. Fine. Now look at the denominator. Are you getting some Pythagorean identity? Yes, you are perfectly correct. This is nothing but cot square. So the cot square in the numerator and denominator will cancel at this moment. So this and this gone. What you're left with is cosecant theta minus 1. And this is nothing but your left side. So both LHS and RHS are equal, hence verified. Now see, in a math problem, there can be multiple ways. If you look at the answer key, they have done a little different method. That is also okay, but the method which I did here is also fine, as long as you are getting correct answer in smallest amount of time. Okay, let's proceed with 26. Now I'll ask you the same question. Which side should we begin with? Left or right? Which one is more easy? Any direction you can begin. Now let me begin with left side first. So cos theta, nothing I can do, but cot theta, I can apply quotient identity because cot theta is cos theta divided by sine theta, right? So what do you get after simplification? Cos square theta over sine theta. Now can I do anything more at this step? Nothing. So I stop here and move to the right side. Let me see if right side can also be coming equal to the same thing. Okay, so we'll write the right side, cosecant theta minus sine theta. So I can use cosecant theta reciprocal identity. So cosecant theta can be written as 1 over sine theta minus sine theta. Again, I'll take reciprocal. Sorry, LCM. So LCM is sine theta, so 1 minus sine square. Again, you are now easily being able to identify, looking at the square term, that 1 minus sine square is Pythagorean, converted to cos square. And now we are almost done because both sides, left and right, have come out to be the same thing. Left hand side is also this. Right hand side is also this. Both are equal. So as long as your left and right side both are equal, we have verified the trigonometric identity. Amazing. So that completes 25 and 26. Next coming up is 27, 28. And by now, I think you have got an idea how to be solving these kind of questions from Learning Objective 16, Lesson 11.2, Verifying Trigonometric Identities. So let's continue and now start with this side. Obviously here, there is no confusion. This side is more tricky. So we will start with left-hand side and we will be using definitely some identities along the way. Sine theta, cos theta already simplified. So we can convert tan theta as sine theta divided by cos theta. And let's see what we get then. So sine theta, cos theta, sine theta over cos theta plus cos square. Cos square, I can't change anything, right? So let me see what cancels. Cos goes with cos. Sine theta multiplied with sine theta is sine square theta plus cos square theta. So such an easy question equal to 1, which is right side. So I hope you've understood that as long as both sides are equal, we have verified the identity. So this is how I need all the steps when you are doing it in a free response question, paper-based, mention in brackets which identity do you use. For example, I use tan theta as sine theta by cos theta. I use it here when I substitute. Also, I use Pythagorean if you see. I use sine squared theta plus cos squared theta equal to 1. Pythagorean identity. So please mention questioned, Pythagorean, reciprocal, whichever identity you are using in brackets so that you get full marks and you don't lose steps marking. Okay, 28 now. So in 28, this is already simplified right side. I can't do much about it. So I'm going to begin with left hand side. Let's do it. And while I solve my left hand side, I use reciprocal and questioned identity. So cosecant is the reciprocal of sine. So 1 over sine. Cot is the quotient of cos theta over sine theta. So put the values, take the square. Again, we can take LCM, very, very easy. Sine theta common. So on the top numerator is this, and everything is square, don't forget. So now we open the square. So I'm going to write 1 minus cos square. See, one way I can do is use identity. Open the identity a minus b whole square, but I will not do that. Reason being, my right hand side is in a different form. So I can directly after this step write denominator as sine square and numerator as 1 minus cos theta, 1 minus cos theta. Just writing the two factors and not opening the brackets as such. Now, looking at the right side, you have to decide what step you want next because you want this left side to be coming equal to the right side. So for that, I will replace Pythagorean now. So in place of sine square, I will put 1 minus cos square so that in numerator and denominator, at the next step, something will cancel. And what is that something? I'm sure you are able to identify. In the numerator, 1 minus cos theta, 1 minus cos theta. There's only negative. But in the denominator, this is like, I will write here a square minus b square. Difference of square identity. So one will be positive, while the other will be negative. So which term cancels? I hope you're able to identify 1 minus cos theta, 1 minus cos theta goes, and you're left with nothing but the right side. Let's check 1 minus cos theta on the top and 1 plus cos theta in the bottom. Yes, that's what we got. So therefore, we have verified that both sides are equal. So question 28 is completed. Okay. So a lot of questions on verifying trigonometric identities we are solving today. We have 4 more questions left, so let's finish them also. Many students had requested me for revision and video on this topic, so I will do for all of you. And then I will post the recording later. Okay, now I hope you're able to identify out of these. We have to begin with right side because it has more options for us to simplify. So I'm going to replace cosecant theta with its value. So cot square theta plus sine theta multiplied with cosecant is the reciprocal of sine. So I will do that. Now you will see some cancellations happening. So we are just left with 1 plus cot square theta, which is Pythagorean identity, cosecant square theta. Now, is this equal to the left-hand side? Check. Yes, it is perfectly equal. So that means we are on the right track. Left and right side both have come out to be equal. So we started with the right side. If you see, we begin with this one and we reach left-hand side. So both are equal, hence verified. Perfect. Let's go to 30 question. In 30 question, I will begin with left side because this is more complicated and has more options for me to simplify. If you look at the right side, this is already in sine and cos, so I cannot do much about it. So let's use some basic identities. and simplify these two terms. So what I'm going to be doing is I will break this left hand side into two terms because there's a negative. So I'll put negative in between and break the numerators. So secant theta, cosecant theta. I break and put the same denominator. So cosecant theta, secant theta divided by cosecant theta, secant theta. Okay, now you must be wondering why I did this and why I did not convert to sine and cos. See, even if you would have done conversion into sine and cos initially at this step, finally you would have got the correct answer. But as I have been telling you so many times, try to do a method which saves your time and gives you correct answer. So why does this save my time? You will get to know now because secant will cancel, cosecant will cancel. So we will be able to simplify this question in a lesser time. Okay, so 1 over cosecant, 1 over secant will just directly take a reciprocal. Reciprocal of cosecant is sine theta, reciprocal of secant is cos theta. So as you see, we took very less time to reach to the right side and we started with left side. So we have verified our answer. So this step, this method saves a lot of time. So try to use those methods which are very easy for you and takes less time. Don't get confused or do complicated values. Let's finish up today's session with the last two questions on learning objective 16, which are these two. So let's begin with 31. Now for question 31, if you see, they are very, very easy in the sense left side is already simplified, sine square plus cos square, Pythagorean. So left hand side is 1 because it is Pythagorean. Let's look at right side now. Again, in right side, I can use Pythagorean. I can replace secant square with tan value. So how much is secant square? 1 plus tan square. And there's already a tan square theta. So very easy. Tan square will cancel and you're left with 1. So both sides, left side, right side are equal to 1. So when left and right side are equal, we have verified. So as you see, we have done today a variety of problems, some very easy, for some you have to think a little bit more. But yes, everything will come with a lot of practice, so don't forget on that. Okay, for this one, I begin with left side because I feel like I'll be able to simplify in a better way. And I know secant is the reciprocal of cos. So 1 over cos minus cos theta. So this is my left side, okay? Now, obviously, I will take LCM. And when I take LCM, my numerator will come out to be 1 minus cos square theta. Again, I can go for Pythagorean at this step and get my sine square theta over cos theta. So this is my left side. Now, till now, it is not equal to the right side. So let me begin with the right side now, and maybe I will get something similar. So tan can be written as sine theta over cos theta. I'm using quotient identity and I'm multiplying it with sine theta. So I hope you are able to now very clearly see that both sides have come out to be equal. So when left and right side come out to be equal, we have completed the question and we have verified the trigonometric identity. So with that, all questions starting from 19 to 32 from learning objective number 16 verify trigonometric identities by transforming each side of the equation into the same form has been completed. So I hope today's session was useful for all of you. And now we'll stop the session in a few minutes.